Hey guys, my name is Chris, and briefly today we're going to mention our paper using FPGA devices to accelerate tree-based genetic programming, where we use a relatively recent FPGA device and a preliminary architecture for the evaluation phase of tree-based GP. So to set the scene, we mentioned that AI, in all sorts of ways throughout history, has been continually constrained by computing performance and energy efficiency. So whatever the biases are for computing at the time, it usually constrains AI in all sorts of ways. However, enhanced computing at any given time can sometimes enable widespread adoption. We can look at the case study of this last decade with advancements in GPUs and see that with deep learning, clearly some adoption as well as developments and research funding and so on were enabled by enhanced GPUs. Now, the last decade or so as well, multi-core architectures have been reaching a practical upper limit with how many cores you can have. And this is really due to consistent power budgets, which in general are due to physical constraints. And so because of this, a new trend has been to design more domain-specific architectures or specialized circuits or systems for particular application domains. And this is interesting because in the case of GP, very few DSAs have been established. There are some, but not that many. And this is notable since GP in many cases is able to enable and leverage massive amounts of parallelism. Now, for designing DSAs, the most traditional and most flexible route is still to design an application-specific integrated circuit or an ASIC, but these are expensive to design. And this is not the only route. We can use reconfigurable computing systems like a field programmable gate array or an FPGA. Now, in the past decade, or in decades, but especially the past decade, FPGA technology has become increasingly powerful. So FPGAs are now these complex SoC devices that have these useful coarse-grained components like floating point adders and multipliers, high bandwidth memory, and so on. And this paired with the traditional resources in FPGAs, as well as better tools, allows FPGAs to commonly now leverage more data and function parallelism, as well as energy efficiency when compared to CPU and GPU systems. Depends on the application, but it happens in a lot of cases. And in this work, we study how can we maybe use a recent FPGA to enable potential speedups for the evaluation phase of tree-based GP. Yet in the long run, we want to explore, can we enable enhanced computational efficiency for all sorts of GP potentially? And can we use this to translate into practical benefits for GP? Faster runtimes, quicker evolutionary searches, and so on. So that's a preview of our paper. And please try to attend our presentation or read our paper. Thanks.